Okay, this is lesson 4.3b, and we're going to continue investigating transformations of quadratics, but this time we're going to try to draw some conclusions based on the investigation you did in part A. So in part A, you graphed using Desmos, and in part B here, I'm going to do the graphs, and we're going to try to make some connections between equations, descriptions, and graphs. So let's look at our first graph here. It says graph the quadratic equation y equals x squared plus 2. On this graph, I'm going to draw the original parabola first. I'm going to graph the y equals x squared parabola, and we're going to get very comfortable graphing this parabola because it's a pretty important parabola. So it starts at 0, 0, and then to get the next 2 points, we go over 1, up 1, and this way we go over 1, up 1. To get the next 2 points, from this point, we go over 1 up, 1, 2, 3, to 2, 4, because 2 squared is 4. And from negative 2, we go up to 4 as well, because negative 2 squared is 4. And this is the original parabola y equals x squared. And if you base all of your graphs off of y equals x squared, it's going to be easier to come up with your new graphs. Well, let's do y equals x squared plus 2. From the investigation, we might have been able to come up with the conclusion that it shifts up 2. So if we wanted to come up with a graph, well, what would we do? From y equals x squared, we would take that graph and shift all the points up 2. Because this transformation is called a vertical translation. And that's a shift, any sort of shift, left, right, up, or down, and it's up 2 in this case because of the plus 2. So what would we do? Well, if we wanted to steps to graph y equals x squared plus 2, how would we do that? Well, first we would graph y equals x squared, which we did, y equals x squared, the original graph, and then we would shift each point up 2, and up 2 because of the plus 2, as we saw in the investigation, up 2. So let's try that. Well, each point up 2, 1, 2, 1, 2, 1, 2. 1, 2. Notice we're not changing any of the x values. We're just shifting each point up 2. Y equals x squared plus 2, up 2. I'm going to highlight this in pink. And now we just made this graph without using a table, but we could use the table to check. How do we do that? Well, negative 2 squared is 4 plus 2 is 6. Negative 1 squared is 1 plus 2 is 3. 0 squared is 0 plus 2 is 2. 1 squared is 1 plus 2 is 3. And now we have our symmetrical 6. Let's go check. Negative 2, is it 6? Yes, it is. Negative 1, is it 3? Yes, it is. 0, does it give you 2? Yes, it does. 1 gives you 3. 2 gives you 6. We got it right. So this is called graphing using transformations. If you can pick out the transformation, you can graph the original and then shift it up 2. Explaining words what the graph of y equals x squared minus 5 would look like. Well, it would be the y equals x squared parabola shifted down 5. Why down 5? Well, because of this minus 5. Let's try the same question in the opposite order. Instead of giving you the equation, asking you for the transformation, let's give you the transformation, see if you can get the equation. Write an equation that results from a graph of y equals x squared being translated 8 down. Well, that would be y equals x squared, and since we're going 8 down, it would be minus 8. And there we go. That's vertical shifting. In part B of the investigation, we looked at A values. So this one has got y equals negative 3 x squared. Well, this has got two parts here, a negative sign and a 3. The negative does something and 3 does something. The negative reflects the graph vertically. It turns it in from a smile to a frown. Remember y equals x squared? Let's graph it. 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. There's y equals x squared. So our new graph, this negative 3x squared, is going to be the same graph but upside down. So you could flip it now if you wanted to. The 3 is a vertical stretch. And the reason why is because it's multiplying all those values by 3. And when you multiply something by 3, it gets bigger. So it's like stretching it to a bigger number. So how do we graph this equation? Steps to graph. Y equals x squared. Nope, wrong equation. Negative 3x squared. Well, how do we do it? Same first step. Graph y equals x squared, which we did. And then, what do? Well, if we're stretching and reflecting, stretching is multiplying. So what we are going to do is we're going to multiply all y values by negative 3. How come negative 3? Well, because that's the number in front of x squared. That's the number that's being multiplied by x squared. And there it is there. Multiply. So let's try that. 4 multiply by negative 3. X doesn't change. We go all the way down to negative 12. 4 multiply by negative 3 all the way down to negative 12. 1 multiply by negative 3, we get negative 3. 0 times negative 3 is still 0. 1 times negative 3 is negative 3. And there we go. We have an upside down parabola that's really narrow because it's been stretched. It's 3 times steeper. And there's our y equals negative 3x squared. So if we have a number in front of x squared multiplying, what we do is we take all of the y values of the original and we multiply them by negative 3. Let's check the math. Negative 2 squared is 4 times negative 3 is negative 12. Negative 1 squared is 1 times negative 3 is negative 3. 0 squared is 0 times negative 3 is 0. 1 squared is 1 times negative 3 is negative 3. And there's our symmetry. And if we check those points, negative 12, negative 3, 0, negative 3, 12, negative 12. There we got it. So whatever's in front of the x squared, if we want to come up with a new graph, of course we could make a table, but if we wanted to do it using transformations, we would just take all of the y values of our original parabola and multiply them by what's in front. So what would happen if we had a number less than 1, 1/3? What would that look like? Well, if you're multiplying numbers by 1/3, those numbers are going to get smaller. So this graph is going to get flatter because instead of going up to 1, it's only going to go 1/3 of the way. Instead of going up to 4, it's only going to go 1/3 of the way. This graph's going to get pretty flat. That's called a compression. It will be compressed vertically. And by how much? Well, it's going to be a third of the size of what it originally was. And that's called by a factor of 3, because it's a third of the size. How do you get the factor? Well, whatever the number in front of x squared is, if it's a number less than 1, like a fraction like a third, you flip that fraction. That's the factor. The compression part is because it's less than 1. So if a is less than 1, it's compressed. And you take the 1/3 and you flip to get 3/1. That's your factor. We're going to do a lot of work with this, so don't worry if this is a little weird. The understanding of the 1/3 a is something that you're going to work on for the rest of this year and even into next year, but hopefully at some point it becomes solid. The fact that this number is less than 1, the graph's going to get flatter, which means compress. By what? Whatever that is, flip it, and that's what it's going to be. So let's try to come up with an equation here. Write an equation that results from the graph of y equals x squared being stretched. So we're getting bigger. So that means it's going to be bigger than 1, stretched vertically by a factor of 6. So this would be y equals 6x squared, because we're getting stretched by a factor of 6. Now, if the question said compressed vertically by a factor of 6, our answer would be 1/6 x squared. The compressed tells you that it's a fraction, and the factor, if you flip it, gives you your a. That's not part of the question, that's just an aside. All right, that was investigation B from yesterday. The number in front of x squared, the a value. Whatever the a value is, multiply all your y's. And part C. Part C was, what happens if there's a number inside the bracket? Like y equals x minus 4 squared. And this one was a little weird because it moved not necessarily in the direction that you expected. If you did the investigation, the number in the bracket actually told you the opposite of what you expected. Like, so say x minus 4, you'd expect to the left 4 because negative 4 is on the left side, but in fact it was to the right 4. And that was something we had to get used to. And the reason why is because if we have this format, x minus h squared, for this one, h would be the number 4 because we're taking x and we're subtracting h. What's h? We're subtracting 4. That h value tells you which direction we're going to move. The number positive 4 is to the right. So I'm going to write a little note up here. H, the number in the bracket, will always have the opposite sign than in the equation. So what's that mean? Well, h is going to tell you which direction we're going to shift, and if you did the investigation yesterday, you saw that h was a shift left-right. If h is 4, because of the opposite sign, this is going to be 4 to the right because right is positive. In this one, h would be negative 10, opposite sign. So we'd expect this one to shift to the left. It's kind of a spoiler. So let's see if we can come up with a graph. Well, let's start by graphing y equals x squared. And we should be pretty good at this graph by now. There's y equals x squared. And if we want to graph this one with an h of 4, this would be a horizontal shift. I'm going to say translation, because remember translation means shift. Translation, and then h is 4, so that's right 4. Just remember for the one in the bracket, it's like we called it the wacky bracky. This bracket is wacky because it does the opposite of what it looks like. Negative 4 we think would be to the left, but it's actually to the right. It's always just going to be the opposite. So how would we do this? Steps to graph. Whoa, graph y equals x minus 4 squared. Well, that minus 4, there's your y. What do? We do graph y equals x squared, which we did, and then shift all points 4 right. So 4 to the right. Let's start here. 1, 2, 3, 4. 1, 2, 3, 4. From here, 1, 2, 3, 4. Should end up with the same shape. 1, 2, 3, 4. Hey, same point. 1, 2, 3, 4. And if I connect, oh, I missed a point. There's our y equals x minus 4 squared. I'm going to go over in yellow. And there we have it. There's a horizontal shift. So just remember the wacky bracky, whatever number appears in there, minus 4, it's the opposite of what you should expect. Negative 4 we think is left, it's actually right. So what would this one look like? X plus 10. We would think it'd be to the right 10, but since h is actually the opposite sign, this is y equals x squared shifted 10 units left because it's negative. Let's try to go and build an equation. Write an equation that results from the graph of y equals x squared being translated 8 units right. 8 units right means h is 8. So what's our equation going to look like? Well, if it's y equals x minus h squared, h is 8, our equation is going to be y equals x minus 8 squared. Let's see if this checks out. In the equation, it should look the opposite. Negative 8 we would think it'd be to the left, but since it's the wacky bracky, 8 units to the right. So we're good. All right, so if you've noticed, both parts B and C kind of have something weird about them. A is pretty intuitive, up or down. C is fairly intuitive, left or right. It's just that wacky bracky is displaying the shift differently. So hopefully that helps solidify some of the investigations. Our goal by the end of the next couple lessons is that we're going to be able to graph parabolas with all these transformations at once. So shifting left, right, shifting up, down, and stretching, compressing, or reflecting. So there's a summary chart here at the bottom. What I might suggest is I'm going to explain this whole summary. If you feel like you got a pretty good grasp on this right now, you might want to skip to the end of the video and see it filled in, or just go to the class website and look and see it filled in. But I'm just going to go over all these transformations again to see if we understand them fully. So it's up to you whether you want to stick around for the explanation. If you don't, that's it for lesson 4.3b. I'll see you next time, but if you do, hang out for about 5 minutes and we'll go through all these transformations one more time. All right, so summary. We've got x squared plus k. So if we have a number being added after the squared, we can either shift up or down. We shift up when k is bigger than 0, when k is positive. And when k is negative, it's a shift down. So that's a vertical translation. And whatever k is, so if k is 5, it'd be 5 units up. And if it's negative, it's a vertical translation. K units again, and it would be down. So what's an example? Well, if we had y equals x squared plus 7, we'd be shifting up 7. And write that here, up 7. If we had y equals x squared minus 7, that would be down 7. A was a little tricky. Let's just start if A, what color did I use for A? I think I used green. Let's first talk if A is negative. So if A is a negative number, that's going to be a vertical reflection. So that's where we flip the graph. And we kind of talked about that one from the beginning of the unit. And it's called a reflection over the x-axis because it flips from top to bottom. And that would be like if we had something like this, y equals negative x squared. And there was 2 more scenarios. If A was a number bigger than 1, so like 2, 3, 4, 5, 6, or if it was like negative 2, 3, 4, 5, 6, that's fine too. It just means it has a reflection as well. But if it's a number bigger than 1, it's a vertical stretch. And we say by a factor of A. So whatever A is, whatever the number in front of x squared is. So for example, if we had y equals 2x squared, that 2 is a number bigger than 1, so that means we have a stretch. And we would say stretch factor 2. In fact, even if we had a negative 2, negative 2x squared, it would still be stretch factor 2. It would just also be reflected. So it would also just be upside down, but it's still stretched by 2. It was if the number was less than 1 that it was a little tricky. If it's less than 1, it's a compression. And we say by a factor of 1 over A. So you flip whatever A is. So let's try one. Let's say y equals 1/2 x squared. We would say compress factor 2. Because you're compressed by a factor of 2. We would flip the A. Let's pick one that doesn't involve 1. Y equals negative 2 over 3. So since it's negative, it means it's reflected. And the 2 over 3 is a number less than 1, so it's a compress. And we would say compress by a factor of, flip it, 3 over 2. So it can still be a fraction, it's just this fraction is a number bigger than 1. So that factor is always going to be a number bigger than 1. All right, and H. H is your shifting left or right, so it's a horizontal shift. Horizontal translation. So this is if H is positive, and this one's if H is negative. And remember, H is the number here, ignoring the sign. So horizontal translation, H units. And if it's positive, it's to the right. But remember, if h is positive, that means in our equation, we're going to have a negative number because h is the opposite sign of what's in here. So this would be a shift right 4. And the opposite's true if h is negative. So this would be like, say, h equals 4. And this would be like h equals negative 4. So h equals 4, h equals negative 4. Now you can see it there in the equation. H is 4. Opposite sign. So if it's negative, horizontal translation, h units, and this one's to the left. And in our equation, it would look like this. Opposite sign. If h is negative 4, we'd have plus 4. And this is a shift left 4. And there it is with the opposite sign. So h will have the opposite sign of what you see in the equation. So there we go. So what do we need to be able to do? Well, realistically, we need to be able to look at these equations and describe these transformations. All right, reflection. Vertical. We need to look at these transformations and be able to come up with these equations. And vice versa. And then ultimately we need to be able to graph as well. Oh, I missed a yellow. There we go. For completeness, H is yellow. So that was a long lesson. Remember, this is something we're going to continue to build. We've got like 2 more lessons on all of this stuff. So we're going to keep working on it. Try some practice questions and ask questions if you're not understanding. But that's it for lesson 4.3b. Thanks for watching, and I'll see you next time.